reflection. The start of this is actually pretty elementary school style, which is okay. It goes back to if you fold anything, in this case it's a vest, and the pattern's kind of hard to see, but it has little triangles on it. If you fold it down the zipper, and one half, Miss Ann, thank you for being such a model today. If you fold Miss Ann's vest right down the middle, one half is going to match the other half exactly. So reflectional symmetry, when one half is a mirror image of the other half. Looks exactly the same on both halves. And actually, Pete, thank you for being another model. We took his t-shirt and split it right down the middle. That Under Armour symbol has reflectional symmetry, because one half of the symbol is going to line up exactly with the other half. Thank you two for coming today and being helpers.
With your shirt? No, it was red. Well, it's the heart.
The lettering on almost every shirt goofs it up a little bit. If Zach's didn't have the Knights hockey on it, if it just had the shield could fold exactly in half. The letters throw it off a little bit. Anybody else?
I mean,
if your flowers were in the exact same spot on both halves, Allie's yours might work out.
I have an Under Armour shirt on.
Oh, perfect! The Under Armour matches exactly. I think, Allie, if we split this fox right down the middle. Oh, wolf, right down the middle, I think it would work.
Rings can work.
Flowers are
That's true. If we pretend like every flower is in the exact spot, it could work. But if we try to split Michael Jordan back there, he's not going to turn out so well. Say it again?
Not sure if that would work.
No, that would not work. He doesn't want to be split.
It would be dismembered.
The fancy name for matching exactly is this congruent word. Divides a figure into two congruent halves. Two exact matching parts.
So congruent, should we write that?
It was just right here in the fancy word for two exact parts. So I think this much should sound familiar to you, right? From at least 5th grade, maybe even 3rd and 4th grade. Did anybody's teacher have those fancy mirrors that when you put on the shape, it would reflect it?
No.
I don't have one, but they are pretty
know what you're
cool.
talking about.
It's like a little plastic mirror, and when you put it, there was a shape, and when you put the mirror on the shape, it would reflect the congruent, the exact half.
Like a regular mirror?
No, it was I should have found a picture or found one. Like a little plastic picture if this helmet had a reflection on it. You could hold it up to your shape, it was plastic, and it would show you the mirror image. It was kind of cool. I'll try to find one. So then, our first two boxes have that exact thing. Where could I draw a line, or more than one line, so that one half is exactly the same as the other half? If you have something that could make you a straight edge, feel free to use it. Lunch card, bookmark. Planners work. Question answered?
No.
You just want to tell us? Okay, I'm just giving people a minute to try.
So in that blank space, do we put how many lines are? Sure. All the lines?
Oh, Bryn, thank you. A lot of them have more than one.
Here, right? All the time. Yeah, I got it.
Sure. How many places or lines of symmetry so that one half looks exactly the same as the other?
This one just go.
If you turn your paper, you might see.
This looks like a symbol. Oh, yeah.
If you turn your paper, you might be able to picture more places.
Are there three? No, that is what we're trying to think of. So I got three so far. So we're too much. We like it too much.
I think a lot of people have the one right down the middle for the triangle. I think that's the really obvious one. If it is equilateral, do you know what equilateral means? Equal on all the sides. It could have 3. And it's kind of hard to tell on this one if it is an equilateral or not. To me, like, it looks like it's pretty close and that it would have 3.
How do you know that? It's not.
To me, it looks like the 3 is slightly off, Ellie said. So 1 or 3. How about that? The next one, I saw people do this. Pretend my line is straight. Bryn?
I did this one.
Like this?
Like, no, through, no. Not like that.
Oh, not like that.
I had one.
You had one there?
Yeah.
Through the side, Bryn?
Yeah.
Oh.
That way. That would just be like turning.
Anything else?
The other 2 corners.
Oh. This one has a lot. Whoa. Drake?
Like the top left side and going through the room.
Now do I have them all? 1, 2, 3, 4, 5, 6.
You know, it's not all around the circle.
Oh, so I was trying to count, like, if this one went all the way through, I wouldn't count it again. Does that make sense? But I don't,
Other lines of symmetry are commonly started with the shape of the line. For the triangle with 3 lines and there was 3 lines of symmetry.
good observation. She said if I think that's gonna work if all of the sides are equal. If this was equilateral, Ellie said it's not quite. If it was, 3 sides, 3 lines of symmetry. This one, and you remember what it's called? Hexagon. 6 sides, 6 lines of symmetry. So she was looking for a pattern.
Not a stop sign.
Nope.
Head-on.
Octagon is the stop.
Yeah, that's old.
Oh. This one looks more isosceles to me, right?
Mm-hmm.
So then Godiva's rule wouldn't work because all sides would have to be exactly the same. That's a great rule, Godiva. Thank you. Are we feeling okay about this lines of symmetry thing?
Mm-hmm.
That's more elementary-ish, which is fine. Good to review. 7th grade flips to the reflection word. We wrote that down as one of the choices yesterday. Do you remember?
Yeah.
Reflection is going to flip that whole shape. So it's not just folding the shape in half. The whole, they say figure, I like the word shape better. The whole shape is going to reflect to a new spot. Yesterday, the whole shape slid right or left or up or down. This one, the whole shape is going to flip over the line of reflection. which is just another name for line of symmetry. So when you see line of reflection, you think, oh, the spot that makes both halves the same.
So what should we write this AKA?
Yeah, it's just another name for line of symmetry.
And what was the definition for line of symmetry? A line that is symmetrical because I
Allie wrote, divides a figure with reflectional symmetry into two congruent halves. So you're making two equal parts.
What was this one?
Reflection right here. The transformation that flips a shape. I like to say shape instead. Over the line of reflection. Everybody good? So here's what it's going to look like. Which was my original one again? The black one or the blue one? How come?
because I can't remember. Oh yeah, because the prime marks.
Oh yeah, they're called prime. Did you two know that? Nice job. So the prime, maybe this is hard to see. The prime tells us that's where it got moved to. And so here's my original ABC. And then it said reflect it over the y-axis. So here's my line of reflection. So it's like the whole graph gets cut in half, not just a triangle. And then, this is like my pencil tracing. If B is 1, 2, 3 to the left, B prime 1, 2, 3 to the right. So this line of reflection is like our mirror. Can you see that? What's going to happen?
Mm-hmm.
Okay, so the one you have on the bottom says triangle ABC. Forward 3, up 0. Forward 7, up 3. Forward 5, down 1. Some sort of straight edge. ID card, bookmark, planner. Now we're going to need a line that becomes our line of reflection. This one said y-axis. This one, oh boy, get excited.
Yeah. Whoa.
Says x equals 2. How do we get a line out of that? Preston.
You just make your own Y's? Or no?
Oh,
Oh,
Say it again.
I just said, I didn't see there's a Y. Oh, that's the next one though. You just make your own Y's?
Oh, I know. Like an XY chart you're saying. Yes, I missed doing that. Didn't you miss it?
No.
Oh.
I thought it was fun.
All of the x's must be 2. What y are you going to pick, Preston?
0.
Sure. Mason?
2.
Bryn?
1.
Any why that if you really like 7, you go ahead and pick 7. Forward 2, up 0. Forward 2, up 2. Forward 2, up 1. Look at this special case we just made. Not so straight for me. Now remember what was going to happen? However far right A, B, and C are, go back to the line that we just made and go left the same amount. So how far right is A? From our line? 1. So A prime is 1 the other direction, left in this case. The whole shape is reflecting. How far right is B?
5, 7, 6, 4.
From our line?
4.
I think 5. So go back to our line. B prime. It's really tempting to accidentally use the y-axis or the x-axis, but you'll hear me say this very often. We don't care about those right now. We really care about this blue line, because that is the line that's making 2 equal parts. C is 4 right. Did you get that? So C prime is going to be 4 left. Just like yesterday, hopefully when you're done, they're the same shape. If you fold on that new line, would it make 2 equal parts? Allison.
I have a question though. When we get the line, we're gonna just like follow the edge.
How far
Wait, do we have to
right
prime marks?
than the other one is on the same distance from this one?
So how do we find the line?
Using this. So forward 2, up 2. Yes, put the prime marks. That's how we're communicating with people in a math language. Remember that Mathanese that we were learning? How to write with math?
What does it mean?
Mathanese?
What does that mean?
Kind of like Japanese or Chinese, a language.
We could call it Mathish.
Mathanese.
Polynese. Polynese.
Some of them are a little different, like you speak Italian, not Italian.
Italian. We could call it math, like English, Mathish.
Oh, we could call it Mathish.
Polish.
Okay, we need A, B, and C again. Same A, same B, same C, right? Yeah. Whoa.
Oh, it's the same one.
Yep, to start with. This time, oh, I think I counted up. We need a different XY chart, right? Different XY chart? What's happening in this XY chart?
Pick your own X's. Instead of one.
All the Y's are -3. Drake, which X would you like?
0.
Good job. Pick something crazy, Addison.
4. 5.
So crazy. 4 is the craziest number.
-3.
Over 0, down 3. A lot of people goof this one up. Over 1 down 3. Over 4 down 3. Horizontal special case. I know in first hour, the people that were working ahead of me had 2 vertical lines. They didn't count quite right. So now guess what? The shape that's up here has to reflect down. So how far up is C? Which, use your line, C prime is 2 down. Use your line. A is 3 up. Yes? So A prime is 3 down from the line? Tell me if I'm wrong. Is B 6 up? B prime is 6 down?
This whole thing is so easy.
Whoa, good. Be suspicious if, like, what if my B was down here? Do they look the same?
Same shape.
Why is that one with the cardinal?
Be suspicious that maybe you counted wrong. Because if I fold on this blue line, are they going to be equal?
No.
No. Be suspicious like, ooh, something did not go right. I should try that one again. Remaining questions.
Need graph paper again?
We sure do need graph paper. So there is going to be